Josie from the UK in Berlin, and I don't know, the padlock to me is, I don't know, private browsing, I guess. I'm not sure. It's a level of security, I guess it signifies. I don't know.
He's anxious about it.
Yeah, it's the most British response ever that I mean, assuming it has a sign that is the same as privacy browsing so that you don't have any cookies or other things saved. I can't comment on what they are. I don't really know.
True story.
That's one person. Let's see what someone else who had a little bit more computing experience had to say.
Who are you, and where are you from?
My name is Stan from Canada. I live in Berlin. I get those with fingers up them. Back to the padlock question.
What is the padlock in a browser, and what is
In the browser, I believe I think it tells you that the website you're currently looking at has a certificate that assures that it's safe. Hurrah! Yeah. Hurrah! Yeah. And then sometimes, you get a little warning that, oh, this website doesn't have a certificate, so it doesn't have a padlock or something. Hurrah!
Do you notice when a website doesn't have a certificate?
It pops up.
What does it say when it pops up, and what do you do?
I keep going because the porn is really good.
Yeah, okay. Well, in any case, the people have different impressions of this, and I kind of forgot how that one ended. But in any case, the way to visit a website, whether it's secure or not, is a protocol called HTTPS, and that S stands for security. And what does it really mean to visit a site securely online? And in broad strokes, it means a number of things, but one of which is transport security. So how are the bits of information that you're sending to the service and then that service is sending back to you, how are they encrypted? How are they transmitted? Are they transmitted as clear text, as ASCII, as something that any one of these participants of the internet along the way, you have your coffee shop, your ISP, transit providers, these are the folks who run the backbone of the internet, sending data across. You have cloud providers that may be hosting the service. This coffee shop might be your local network with the rest of whoever it is that you live with. And so what does transport security provide? Well, it takes these intermediaries who are able to pass the data, and it's essential in passing the data from the user to the service and back, and it puts the data in a form that's encrypted so that these folks can't necessarily see it. That may be hosting the service. This coffee shop might be your local network with the rest of whoever it is that you live with. And so what does transport security provide? Well, it takes these intermediaries who are able to pass the data, and it's essential in passing the data from the user to the service and back, and it puts the data in a form that's encrypted so that these folks can't necessarily see it. And so there's an encryption component, and as mentioned by the second person here on the video, there's also an authentication component. And so when a user goes to a service, they need to know whether or not that service is who they are presenting themselves to be in terms of the host name. And so the way this works is with a certificate authority. And a certificate authority is a service. It's a service that's trusted by all sorts of different browser vendors to be able to authenticate a name with a service identity. So Cloudflare.com, Google.com, Bing.com, whatever it is that the site that you're going to, this certificate authority issues them a cryptographic certificate. And this certificate has a public key and a private key associated with it. And so when the user connects to the service, not only is all the data protected, the user also has confidence that the service is who they say they're going to be. And as much as this has something that came around with internet as it was created in the 90s, it also is only something that was used in very specific parts of the internet, leaving almost all of the data that people can send to services, send online and transmit to be unencrypted. In fact, we did a survey of some major sites just 5 years ago in 2015, and all of these major services did not have HTTPS available for their entire site. So you think of Wikipedia here, large news agencies, large shopping organizations. What you did on these sites was not private up to 5 years ago. Luckily, as part of improving the internet, a number of different parties here, and this is, you go back to 2015 where all these previous sites were not encrypted, there was a push to move the web and how folks use the web from HTTP, the unencrypted version, to HTTPS. And this is taken from Google's analysis report, and it's gone up significantly. It's gone up from somewhere less than 50% of connections to sites, pages loaded in HTTPS, to now we're upwards of 90% in some regions and some platforms in the world. So this is really quite a lot. And in fact, if you look from Cloudflare's perspective, I can talk a little bit about how Cloudflare fits into this. It'll be a big part of the third section here. But from the perspective of the server, we've also seen quite a lot of growth. So apologies for the colors not matching here, but there's different versions of transport layer security that have existed, and it's gone from the majority of it being no encryption to now the vast majority is being encrypted. And this is just in the span of 5 years. And these different versions of encryption it's great if the numbers are higher, but the important part here is encrypted versus not. And so if you talk to folks who care about encryption and care about encryption policy and think about how the internet is architected, one design principle comes up pretty often. It's called the end-to-end principle. And the end-to-end principle is a concept in which two parties are communicating and they become the only parties that have access to the data. So this is often used to talk about secure messaging. So if you're using the latest version of Signal or of WhatsApp, these products have end-to-end encryption. So every participant has a key on their devices, and it's used to derive a shared key, and then you can communicate securely. And so people think about HTTPS, they think about encryption, and this end-to-end principle is something that comes up over and over again. And what the focus of this talk is explaining why the end-to-end principle is a great principle, one that actually does work in a lot of circumstances, but thinking about how it applies or does not apply to the web. And the main thing to focus on here is if you think of end-to-end, you have two participants or more participants in group chat. We'll forget about that for a second, but in the web, who are the two participants? The user and the web service, right? Well, it turns out this is not always the case. And so forward.
Hey, Nick.
Yep.
Are you trying to show the slides right now?
Yes, are you not seeing the slides?
It's still stuck on the video. I
Oh,
guess,
okay. Apologies. Yeah, so there are some really nice diagrams that we might have missed. Let me see if I can resume share here.
Yeah, now we can see your whole
Okay.
screen.
So
Yeah,
apologies
we haven't
about
seen
that.
anything since the video.
Oh, sorry. I must have missed that in the chat. Give me one more second while I arrange my windows. Oh yeah, I missed this underneath the window in this sense. Thanks everyone for notifying me of this, and apologies I didn't catch it. All right, so transport security. This would make a lot more sense. All right, so we're talking about these intermediaries no longer being able to see the content. When talking about authentication, we have a third-party certificate authority that authenticates the service, and the user has these ribbons that represent which certificate authorities they they trust, the service proves ownership of that certificate. There's all these organizations here. It's really hard to imagine some of these not having HTTPS as little as 5 years ago, but it's true. It's been a really big upgrade for quite a lot. And so this is the chart from less than 50% to almost 80%. This is the kind of chart where the small corner here represents encrypted in 2015, and it gets inverted here to the orange and red, which are encrypted, versus the green is unencrypted. So it's quite a big reversal. All right, so who in the end-to-end principle are the participants in the web context, and why is it not just the user and the website? Well, first we'll get to one side of the equation in which this can break down, and this is in the case of forward proxy TLS interception. This sounds a little bit clunky of a name, but what forward proxies are services that sit on the user side of things and help provide capabilities that maybe the user's device doesn't have, or help provide services that are related to the network, the local network that the user's in. And so if anyone's spent some time in like a big corporation, you might have dealt with corporate proxies. So if you have a computer and it's plugged into a corporate system, you may have to go through a corporate proxy that does inspection, and it tries to make sure that private data from the corporation is not being leaked. That's one thing in which a forward proxy can be used. Antivirus is another. Oftentimes, antivirus program makers want to have access to all the data that you send out over the internet, so they can look for potential malicious code. This is something that can happen in school with family filters as well, or at home. And in some rare cases, government proxies may also do some inspection here. And so the diagrams we put here on the bottom, or the icons, represent the Kazakh government, who has attempted this, Zscaler, which is a popular corporate forward proxy, as well as Bluecoat, which is known to do this in various organizations. It's part of Symantec as well. So there's legitimate inspection, and these are tools that are useful for when the users are not owners of their machines. So this is, you're getting content that's going through a network that also owns the machine. So this is something that puts you in this realm, this kind of fuzzy, like, I don't really own my data, but I do sort of situation. It's actually very common. The other situation in which forward proxies happens are sometimes less legitimate. So if you think of spyware, adware, or even malware, they can do the same sort of thing. They can install a piece of software on your computer and then look at all the traffic going out before it becomes encrypted. So before it becomes encrypted is the key point here. And this is where the idea of a forward proxy comes in, and how it actually works with HTTPS is rather than connecting directly to the service, what happens is your traffic gets intercepted by this proxy, and this proxy then pretends to be that service. And as I mentioned earlier, it needs to provide a certificate and a proof of ownership of that certificate to the client for the browser to actually trust it and show the locks, the padlock diagram, that icon, and not a bunch of warnings. So in a forward proxy scenario, the user itself has to install this certificate authority that is managed by this proxy. So this is not going to work out of the box. This is not something that happens with your phone. If you go into like a coffee shop or something like this, you're never going to have forward proxies able to intercept it. But if you're in a situation where you're in a corporate environment, you can install this certificate, and then you're able to connect to the rest of the internet. The secondary interesting part here is the proxy then makes a connection to the service on behalf of the user. This proxy is not running the browser, so it doesn't necessarily have the exact same software, But the hope is that the proxy would do the same validation of the service as the user would as part of the browser. And so if the problem here, or one of the many problems here, is that if the user connects to a service and the certificate's wrong, as hinted at by the person that did that interview, you would have all these sort of types of things that come up. So it's actually, yeah, this certificate is not trusted, or this website's not trusted, and then it allows you to potentially click through. In the case of a proxy, there's no way to actually trigger this behavior without the encryption layer actually failing. So you have a choice as a proxy. You can either show a kind of fake error that doesn't allow people to go through, saying the service is unauthenticated, or you can just, you know, if the service itself is not authenticated, the certificate's wrong, or it's an attacker, you could just pass the data through. And so this was a subject of a paper that I did in collaboration with a bunch of folks at UIUC and other organizations a few years ago to actually see how often this happens in the real world, and what happens, whether or not these proxies are built in a way that's secure and that actually validates the certificate on the back end, and which ones are not. And so if you want to check it out, you can go to malcolm.cloudflare.com. This is a live dashboard. And what we break down is, for this research, we took a number of different servers and looked at the incoming connections and tried to discern whether they were made directly from a browser and a user, or whether that browser went through a forward proxy. And we found a striking amount here. You can see here that it's over 10% of the traffic on the internet reaching to sites that use Cloudflare are going through one of these forward proxies. So that's huge. The negative part that we discovered was that going through all of these proxies, they're meant to, or they need to actually implement the latest and greatest and the best versions of TLS, and they need to validate certificates. And it was found that a lot of these different services, whether they're antiviruses or whether they're forward proxies from a corporate perspective, not even looking at any of the ones that were doing this as viruses or adware, spyware, malware, you could say. You can see that some of these validate certificates, some don't. A lot of them don't use modern ciphers, and a lot of them are advertising versions of cryptography that are actually vulnerable. This data in particular is somewhat old, but it does indicate that at the time of this publication, all of the browsers had fixed these issues. But folks' traffic is going through these proxies, and the traffic from the proxy to the service, that's over the internet. So if the analogy of the armored car still makes sense, the route along the internet that the armored car is taking is something that can be manipulated at a much lower level using things like BGP. There's a number of attacks that you can force things to go in different directions. So as some of these proxies are actually vulnerable to problems. Yeah, so given this, given that even the legitimate proxies are problematic in some cases, if you look at the adware malware proxies, there's one called Superfish. This is again from 5 years ago when we started a lot of this research, but it was widely known that, or it was widely advertised that there was a tool that gets installed by default on a bunch of laptops, and this worked as a forward proxy. But one of the problems with this is that it never actually validated connections to the outside world. So it would be live on the machine, the private key is there, it was able to mint these certificates for any site on the fly, and anything you tried to go to, you actually end up going to this malware first, and then it would connect onto the internet with no security. And so the users were left none the wiser. They had their lock icon, and that was about it. And so if you think about the end-to-end principle here, it's for a lot of the internet actually is not end-to-end encrypted because of this architectural decision to have forward proxies, and especially forward proxies that do encryption. Now, so that's not the only reason why the end-to-end principle doesn't apply for a lot of traffic. This one's a little bit different, but it's some of the same concepts, but the relationships here are very different. And so forward proxy, that's something that takes traffic that's going outwards and, you know, does some things for it. What is a reverse proxy? Well, a reverse proxy is something that sits in front of the receiver and does different actions on its behalf. This diagram here shows effectively what Cloudflare does on behalf of websites, which is a reverse proxy. It takes incoming requests, and if there's something that's cached or something that there's a copy of it, it can just return those requests. If there are requests that are bad, it can block them. And this helps reduce traffic to or websites. Like they're called in the jargon that we use is origin server. So this origin server that has the content gets sort of less traffic, less weight. If there's an attack, it can be blocked. And websites will load faster because oftentimes this reverse proxy is located closer to the user than the website is. And so this is a common model. It's in fact extremely powerful. Some of the features it can provide help make sites a lot better. So there's caching, I mentioned firewall, there's something called web application firewall, which is blocking attacks, SQL injections, and things like this. General DDoS protection, global load balancing. So if one server goes down, you can keep things going. TLS, which is the interesting part here, is you can actually do the TLS termination, like the proof of certificate, at the location of the reverse proxy. And this is, as of a couple weeks ago, the market share, still 80% of websites don't have a reverse proxy service. That's a third party. But that leaves a very good percentage in the teens here that use one of these many services that does reverse proxy. So what's the difference between a reverse proxy and a forward proxy in the technical sense? Well, first of all, with the reverse proxy, the service has to sign up for it. So if you're a service and you sign up for a reverse proxy, you actually have to point the world's view of where your server lives, which is in the domain name system, to the proxy. So you're delegating authority for serving your website to this proxy service. And so in doing so, you also need that proxy to be able to be the TLS server for the website and web content. And so when users connect to the proxy, the service provider, oftentimes they'll just give the certificate to the third party, whether it's Cloudflare or some other reverse proxy. That's one way that it can happen. Another way is that the proxy itself can, because it's authoritative for traffic on that domain, it can get a certificate issued for itself for that service with the service's name. And so users don't have to opt in. This is something where for forward proxies, users need to opt in by adding that proxy certificate. For reverse proxies, it's the service that needs to opt in, and the service needs to effectively extend its trust boundary outwards to this proxy, and this proxy becomes the outer face of the service. Where things get a little bit sticky is actually setting up the connection between the proxy and the origin server. And so for Cloudflare, for instance, and it's the same for almost every one of these other services, you can set it up various different ways. Flexible is the first one, in which the browser to the proxy is encrypted with HTTPS. The proxy has a copy of the certificate. It can do all that stuff, and to the browser it gets the padlock and everything's good. But the connection from the proxy itself back to the origin server is not encrypted. Then there's full, which both sides are encrypted, but the certificate is not validated on the Cloudflare to origin server side of things. And the final one is strict, which is, this is the strongest version that there is here, where connections come in, they're encrypted, and then they go from the proxy back to the origin server and are encrypted. And if you look over the entities of the internet that will have access to traffic here, we're talking about your router, your modem, your ISP, internet exchanges, all the wide internet. This is protected by the first half. And then from the reverse proxy, it has to go back over through the internet back to the origin server. And so in flexible and full mode, this is potentially vulnerable. Yeah, and you may ask yourself, why is it that folks would use flexible or full versus strict? Well, in part of the mission of getting as much of the internet as encrypted as possible, some of these origin servers are hosted by third-party hosting providers that may not have been able to automatically interact with certificate providers, or they are unable to host certificates for one reason or another. And this has been a problem for a lot of different hosting providers. And so in doing so, you have to actually get HTTPS for your site and for users to actually see it, you need to put a third-party service like Cloudflare in front. And for Cloudflare to reach back to the origin server, sometimes it just takes a bit of work to set it up, and not everybody does so. And so there could also be situations where the origin server has a certificate, but it's like a self-signed certificate, or if it's not for the right name that the for the actual website, it's more of the name of the hosting provider. So I'll get into this a little bit later, but it's really these three options are ones that it's up to the choice of the user. And there are really strong technical reasons for doing all three, but it's sometimes hard for folks to actually decide which one to use. Okay. We have reverse proxies, we have forward proxies. I had kind of hinted at, you can change the lights and make the armored car go anywhere. Well, I'll lay out some real examples of this from the last several years. So I mentioned forward proxies here. From the user to the proxy is protected, and then the proxy to the service is potentially not protected. There's a lot of things that happen. This is over the internet, right? So let's see, I think I do see some questions here. So let me know if I should. Yeah, maybe we can answer the questions at the end. We're gonna have a lot of time. And I'd love to get into the details of this, and folks can point me back to the right slide when we get into it. But for forward proxies, sometimes this proxy to the service, that's less secure. So here's two examples of situations in which that would have made things a lot worse or were taken advantage of. One is, these are both from 2018 actually. So Coffee Miner. Coffee Miner is a man-in-the-middle MITM attack. This is, we prefer the term on-path attacker now. These things have evolved over the last few years. But the idea of an on-path attacker is that somebody in the coffee shop is changing the bits and bytes as they go by. If you're on a network in which there's no authentication and encryption, which often happens, it's often the only availability of internet in your region. What someone can do is look at the actual content of the website and put in something in there, like a cryptocurrency miner. And so this is actually what happened here for this this thing where Monero is a specific type of cryptocurrency that was being mined. And so if a user was actually using one of these forward proxies on the machine, say an antivirus machine that did things incorrectly, then this proxy to the service connection is one in which this coffee miner could be embedded in. It wouldn't, in this scenario, you can embed it only in the unencrypted websites you visit, but given this, it may be actually able to be embedded in the encrypted sites you visit. And there's a very big difference, and browsers have been trying to push servers to move to HTTPS by limiting certain features to HTTPS, including access to the GPU. And so being in a situation where you have this forward proxy puts you more at risk to something like this coffee miner. A second attack that happened in 2018 was less of a local attack, but more of a global attack. There were these services that connected over the web using a browser connection in which the attacker was able to reroute the traffic to their server before it reached the actual destination server. And so anytime someone would see that, you'd get one of these pop-ups that says, hey, this is insecure, or the certificate doesn't work, because they didn't have a valid certificate, the attackers. In the scenario where you're going through a forward proxy that is not validating certificates, then you wouldn't even see this. You would just be connecting directly to the site, thinking that everything's fine with the padlock, and then these hackers would see the content of your connection, whether it's your password or your cookie, or a cookie that lets you log in, and we're able to take that and pull it to pieces. So it did affect people who are not using forward proxies, but a forward proxy, because it doesn't give you that prompt that like, hey, by the way, something's wrong, can put you in a much worse situation with respect to this. So this warning is something that's very fundamental to HTTPS that you just can't do with a proxy. At least you can't do in a way that's native to the browser. So going back to these two examples, like if there's a forward proxy, the user might not see an error if there's a, say, misissued certificate. There's a whole system out there that's been over the last 5 years called certificate transparency that's meant to catch certificate authorities who issue certificates that are not following the rules, meaning they didn't validate the name of the website properly. There's also revocation. If somebody says, okay, well, my private key is compromised, this certificate doesn't work anymore, there's none of these forward proxies does any checking for revocation. So you could be in trouble there as well. If there's an old expired certificate, this is a little bit out there, but if the certificate is from 2018 and has been expired, if your forward proxy, their clock is in 2018, then these certificates could still work. Same with certificates that were issued by a certificate authority that may have been kicked off the trust store for some reason. It's very, very difficult for a proxy provider to keep up their security with at the same par level as a browser would, because browsers have whole teams dedicated to this sort of thing. If there's no validation, you can just use any certificate, and you don't see this, you just see where you're going to, but you don't get the trust that you expect. Traffic manipulation attacks for reverse proxies. Well, I'm going to go over two stories of when this actually happened. So you can think of the service here as like the customer of the proxy. And so the service has signed up for the proxy, and then they use something like flexible as their configuration. This happened this is from a public Medium post, but this happened in India, where users who would visit the piratebay.org would end up getting a pop-up from Airtel. And even the funny thing was that even users who weren't using the ISP Airtel, they were using, say, Tata, they would still get this pop-up that was on an encrypted site. And this for folks who had like a brief, like a cursory understanding of how HTTPS works, this didn't make sense. This meant like whatever the proxy was doing, they were incorporating some type of these censorship information into the connection. And so this was this was pretty challenging and pretty difficult to explain. Like, how would somebody who's just looking at the actual network itself be able to inject something into a trusted encrypted stream that says it's like that you shouldn't be viewing certain content, and it could even be from a different ISP. So the interesting resolution here is that actually one of the data centers in India used Airtel as its way of connecting to the internet. So the customers went through Tata to the Cloudflare reverse proxy. Reverse proxy used Airtel to get to the Pirate Bay website. And this was it was theorized here in the Medium post that the customer used Flexible, and then that Airtel itself was looking at the plain text data. So as far as the user was concerned, it looked like it was locked and connected, but this gap here on the back was being used by an intermediary, in this case the ISP, to change the content. So this was a pretty odd situation. And so this isn't the first time that this has happened. There was another situation where some website saw that they had an HTTPS. They had something that they didn't add into the page, something that wasn't not supposed to be on their page, added to their encrypted page. And it turns out that they had configured it in full mode. And then an attacker had done something called ARP spoofing in their hosting provider's data center to reroute traffic, provide a fake certificate, and then use it to just inject an extra script into their site. And the script was very damaging. So this is another example of this happening in real life. So if you're going from hop to hop to hop, every single one of them needs to be the highest security to really be assured that the content is what it is supposed to be. So this is flexible, full, and strict again. One of the things that we wanted to do in this case was make sure that users, customers could actually be in the most secure mode possible, which it turned out to be a very difficult problem. So we had a survey that went out, and why are you on your current mode is what we asked customers. And some people said it's secure, some people said I don't have a valid certificate, or I have multiple origin servers, or the majority just didn't really know. And so this was clear that, you know, this is something that most web developers or most people operating websites, it's just well beyond what they're comfortable with in terms of thinking about websites. Usually you just put content there and users get to it. The piping and the infrastructure in between are ones that are these are things that it's sort of taken for granted in a lot of ways. And so we did a scan. This is with some interns who worked with us over the summer, and found that of the people who are already at full, based on different, we created a scanner that looked at the content of the site from HTTP and HTTPS. That's usually the indicator that a site can use something like full strict, is if the content is the same and if the certificate can be validated, then hey, why not use the more secure version? But it turns out that not everyone can do so, which is fine, but there was quite a lot here of customers that, at least for some of their subdomains, could be upgraded. And so this is something that we're coming out rather soon, is to let these people know, hey, by the way, your settings could be more secure. Here's the set of risks, and this is something that we can do on this as well. All right, so this new feature is coming soon. I want to lay out a little bit of a vision for the future here, and I think this one's really challenging because the question comes in here is, if you have a forward proxy or a reverse proxy, cryptography provides a really nice concrete solution for two parties to be able to authenticate themselves to each other, and for that trust to be solid and self-contained and in one piece. But if your architecture looks like you have load balancers and you have different types of data centers and you have different hops, how do you actually prove that the hop before the current hop proved itself to you? And then how do you prove that onwards to the very first connection? And this is a very, very difficult and challenging problem for the current technology that we have. TLS doesn't have this way of asserting that content sent from one connection to the next was trusted by a real certificate authority or something that, like how to actually write that into a language that web servers can understand is extremely difficult. And then bringing it to users is even more difficult, because this is something that this is something that users can barely understand, just a padlock, right? We want folks to browse the internet, be as secure as possible, but we don't want to introduce concepts that are just way too challenging for folks to understand or reason about. And so the vision for the future is really, given the armored cars that we have, there's a couple immediate things we can do before tackling the overall idea of transitive trust. But first of all, it's auditing forward proxies. If you're using a forward proxy in your business, make sure that it actually does the right thing, that it validates certificates. Ask them if they do certificate transparency. They probably don't, but there's ways to improve it. There's ways to make sure that these service providers are held accountable to the highest standards. Making sure that the software can be updated, that's almost the lowest bar here. So if you can update it, then it's likely that you can pick up updates that happen across the whole ecosystem, and you're not stuck in a situation where there's some piece of hardware sitting in a data center that can't be upgraded and is doing old bad crypto and you can't get around it. So there's that. For reverse proxies, if you have a site or service, use strict mode whenever you can. If you happen to be on a hosting provider that doesn't provide TLS support, consider asking for a feature request. And if not, there's other providers that can be there. And setting a good example by using strict TLS is a good thing to do. Some of the challenges for upgrading a site involve things like sub resources. So there are some web tools to look at here for sub resource integrity and whatnot that can help solve these problems. But yeah, with reverse proxies, use the most secure setting as possible. And finally, when browsing the internet and when thinking about risk, it's counterintuitive, but between 10 and 20% of sites and if you're a server, 10 to 20% of users are not actually getting end-to-end encryption when going to your sites. So assuming that this is 100% what TLS provides, it's not what it provides. So it's a great tool for improving privacy and security online, but it's not a panacea. And so, yeah, remember the screwdriver analogy. As much as you have, there's encryption, you can, change the lights and send the armored car all around the world. And if that armored car is not actually armored, you could be bringing folks to a false sense of security. And so, okay, so with this, I'm done with my prepared content, and I'd be happy to go back and answer questions.
Hey, Nick. Just before we go into the Q&A, I'd just like to say we have a quick announcement.
Yeah, so thank you, first of all, Nick, for the talk. I really enjoyed it. Before we go into the Q&A portion, I'd just like to invite all the attendees to events.reflectionsprojections.com/org/attendance and enter a code I will put in the chat. We'll be using this responses to the form to pick winners for a Grubhub gift card giveaway. So please don't share this code with your friends. It is a $20 gift card and there's 5 of them. So please drop your submissions within the next 5 minutes. Yeah, return back to you.
All right. Yeah, that's just the quick announcement we had. So for the Q&A, since I'm not totally sure if all the attendees can see the questions, I think I'll just read each question and then you can answer to each question.
Sure, we have about 10 minutes, so I'll go a little bit quick, but it looks like it's a good set of questions.
Right. So the first question we have is, how are these forward proxies different from SSH tunneling?
That's a very good question. SSH tunneling it's a more elegant solution. It has, with SSH tunneling, you have encrypted connections from one server to the next server to the next server, but you're providing proof of ownership of the key. It can actually, that proof can be proxied across connections. So you're never proving anything about what is sent, but you're really focusing on identity. So SSH tunneling has some nice features that we just don't have on the web. And the web, forward proxies, reverse proxies, these are really, you have two independent connections, one to the proxy and then one to the end result. Thanks for the question.
Awesome. And so our next question is, what have been the negative effects of a tool like Let's Encrypt?
So great question. And I mentioned how this has been a wide industry effort to get the web to HTTPS. Let's Encrypt has been a very big part of it. They're a certificate authority that is free, and there's some automated tools that come around with it. They came up with a protocol called Acme, which is an automated way for issuing certificates. What have been the negative side effects? I'm not sure that there have been negative side effects other than the fact that because HTTPS has become so prevalent, there's been a light shone on whether or not people really understand what this means. I think that's a good thing, but it's also revealed some misunderstandings. So for example, now that you can very easily, cheaply, and basically anonymously get access to a certificate, if you have a phishing site, you can get a certificate for that phishing site. And so when we saw the interviews before, some people thought that padlock meant that the site is trustworthy, and phishing sites are clearly not trustworthy. So that's potentially a risk or a negative downside here. But I think it does reveal more about the symbolism that we're using and the fact that it's very difficult to express the ideas of security and confidentiality and trustworthiness with just a little icon. So thanks again.
Yeah. So our next question is, what are your thoughts on efforts like Google's to make .dev domains require SSL certificates to be attached?
That's a great question. So there have been a proliferation of new domains from ICANN. So .dev has been one of them, .secure, .banking, Berlin, .nyc, whatever. There's a lot of new TLDs, and these have come around during the days where ICANN has been trying to expand their business of selling top-level domains, and I think it makes a lot of sense for you to require HTTPS for some of these top-level domains, especially since it's become so cheap. Well, free for Let's Encrypt and so easy to get access to what's called, SSL certificates. So I think it's a good thing. .dev is a little funky because you have to do things on your local host sometimes, and getting a trusted localhost certificate is funky. But there are some tools that have been released to help automate that as well. Thanks. Next question.
Yeah, so our next question is, do you have a breakdown of the percentage of Cloudflare sites on each of the flexible, full, strict, and origin pull configurations?
Yeah, so I can't share that yet, but this is going to be part of the measurement study that I've been working on with these interns. So let's say that there's quite a lot. it's just a plain fact. There's quite a lot.
And then we have, so ZMAP can scan IPv4 addresses. How can you efficiently scan the IP6 space?
Yeah, so this is a question in regards to our measurement study with Malcolm. Actually, for Malcolm, we are measuring from the server side. So we're not actually scanning sites to see what they have. We're waiting to see if there's incoming connections to sites. I don't think there's an efficient way to scan IPv6. So that's an unfortunate side effect of the rolling out of new technology, but it wasn't necessary for this.
Our next question is, why wouldn't one need a forward proxy at all, except to access geoblock sites? Isn't it easier to build an API getaway, like a kind of reverse proxy?
Yeah, so the question here is really about the difference between the two. Forward proxies are almost always used by organizations who have users, who have, say, employees or something like that, or students. So it's really about everybody who's part of one group, and they're reaching out to the internet to access them. You can't really set up an API gateway for all sorts of users because your gateway doesn't have a trusted certificate, if that makes sense. So gateways are for service providers, forward proxies are for groups of people.
Our next question is, do some reverse proxies not allow TLS support at all? Or is it just that some of the connections they allow do not have TLS enabled?
Almost all reverse proxies support TLS or not. It's really about how it's configured. So you can configure it to say if the inbound connections are TLS, then the proxy connections are TLS, whereas the inbound are plain text, the outbound are plain text. There's a lot of different ways of configuring it. And people who choose to configure it in different ways, often it's just they pick whatever works and go from there. So. Here's another question. We're coming to the end here. So why does Cloudflare even offer an option of no encryption? Full, strict, and flexible may be necessary, but what about the off option? Yeah, so that's something I didn't mention, but there is an off option, and this comes down to user experience. Sometimes a site has sub-resources, say JavaScript or images that are hosted on a plaintext HTTP site, and then you're gonna get a big, loud, insecure, or some of the things will be blocked if you go over HTTPS. And so that's part of the challenge of upgrading a site to HTTPS is you have to upgrade all of the things underneath it. So off lets folks who haven't made that transition yet still have their site work and have people not accidentally go to the encrypted version of their site and see something broken.
Hi, yeah, sorry, my connection fizzed out for a sec. Did you answer the question about why which of these attack vectors apply to traffic internal to a VPC or VLAN?
No, I didn't lay that out. So I think, yeah, there's a whole category of attacks that work on one and the other. Basically, it boils down to whether or not you're using a local area network versus an internet wide routing protocol, and so there's quite a lot of ways in the LAN to see everybody's traffic.
Awesome. And then the last question we have, and that we'll take since we've reached the top of the hour, is will Dane ever play a part of TLS for HTTP?
So Dane, if folks don't know, this is a way of putting certificates, well, not certificates, keys, authentication into the domain name system. It's got not a lot of adoption, especially not compared to HTTPS. It doesn't provide any privacy either. It's just authentication. There's been proposals for helping bridge the gap between HTTPS, which is all based on PKI, and Dane, which is all based on the DNS hierarchy. It's too soon to say whether it'll happen, but there has not been a lot of momentum lately towards merging the two.
Awesome. Well, that is all the questions we're able to take. So yeah, that puts us at the end of the presentation. So thanks for everyone for coming out today. And of course, thank you to Nick for this excellent, very comprehensive presentation. I personally learned a lot. I thought it was great the way you explained and broke down some of the concepts that you brought up. So yeah, thanks everyone for coming.
Oh, real
Great,
quick.
thanks for having me.
Oh, sorry.
Yeah, sorry.
Just real quick for our attendees, we do have a Goldman Sachs Tech Talk right after this. So if you would like to join us for that, please look at our website, reflectionsprojections.org, and we'll see you there. But yeah, thank you, Nick, so much. We really enjoyed the talk. Thank you for coming in.
Thanks, everyone.
Yeah.
Bye-bye.